You are listening to The Vocal Technologist. Spoken tech for your ears.
If you work in software, you know the feeling. You step away for, 5 minutes?
If that.
And suddenly, there's a new framework, a catastrophic outage everyone's talking about, and a whole new way to think about AI architecture.
It is an absolute fire hose.
It really is. And staying current isn't just a nice to have anymore. It's basically an operational necessity.
Mm-hmm.
And that is exactly what we do here at Vocal Technologists. We gather up the most essential, the most eyebrow-raising tech updates from the trenches for you every week.
And today we're really cutting through it all. This is, I think, a crucial breakdown for anyone building or architecting systems right now. We've got three main areas.
Lay them out for us.
Okay, so first, we are dissecting the architecture of these next-gen AI agents.
Mm-hmm.
We'll look at how the big players are building these really complex, multi-step systems without just, collapsing under the weight of it all. Second, we're going to pivot pretty hard over to infrastructure. We'll review some painful lessons from the big outages recently and those surprisingly expensive cloud config mistakes that everyone makes at least once.
Oh, I've been there.
And finally, we're going to get into some serious development philosophy. We'll even look at the controversial opinion that object-oriented programming might be the single worst thing to ever happen to software development.
That is a bold claim. I'm excited to unpack that one.
Let's start with the future. Let's start with agents. Building these complex, multi-step AI systems it's really become the defining challenge of the year.
For sure.
And if you're developing an agentic app, you hit this core design decision almost immediately, and it determines your entire architecture.
Which is?
When do you use subagents, and when do you just deploy other agents as tools?
I think a lot of people just hear the word agent and assume they're all the same thing. But that distinction, tool versus subagent, that's critical, right? It's all about complexity and managing state.
It absolutely is. Think of agents as tools, as these highly efficient, self-contained specialists.
Okay.
They're stateless. They don't remember anything from one interaction to the next, which makes them perfect for these discrete, reusable atomic functions.
Like what? Give me an example.
If you need a little utility that just converts natural language into a block of SQL, that's a perfect agent as a tool.
One shot, reliable, does its job. Got it.
Exactly. They're like the utility classes of the AI world. Subagents, on the other hand, they're more like delegated team members.
Okay, so they're stateful.
Right. They're built for stateful workflows. They share context. They maintain it, which means they can handle complex multi-step processes. Think about managing a flight booking or a customer support chat where you need that history.
And they stick around for the whole mission.
They stick around. They can even communicate with other subagents. It's a whole different model.
And we're already seeing that just throwing more resources at this problem doesn't work. I mean, look at Dropbox. When they were evolving their Dash AI, they found that just adding more tools, more context, it actually made performance worse.
Yep. They ran straight into what they called analysis paralysis and the dreaded context rot.
Context rot. I like that.
This is such a profound architectural lesson. The agent doesn't need all the information you can give it.
It just needs the right information.
The right information. And Dropbox's solution was, it was brilliant and just ruthless in its focus. They had three key strategies.
Okay.
First, they took all these different retrieval options, document search, calendar lookups, email scanning, and consolidated them into one single universal search tool.
So the agent only has one way to look things up.
Exactly. It streamlines its whole decision-making process. Fewer choices, less cognitive overhead for the AI.
Makes sense. What was the number two?
Second, they used a knowledge graph to filter the context, making sure that only the most relevant information for that specific query ever even reached the agent's prompt.
So they engineered the context before it even hit the LLM.
They pre-processed it. And third, they created specialized agents, those subagents we just talked about, to handle complex meta tasks like constructing the absolute perfect search query before the main agent even starts working on the user's request.
That's smart. It's delegation.
It's delegation and pre-processing. And that focus on efficiency brings up the cost, which right now is all about tokens. We're seeing some pretty radical efforts to cut token usage, like moving to a code execution environment can apparently reduce costs by almost 99%.
99%?
Yeah.
That's not an optimization. That's a different business model.
It is. This is one of those strategic insights that just changes the unit economics of what you're building. See, historically, agents use what's called Model Control Protocol, or MCP, tool calls.
Okay.
MCP is just the standard way a model says, hey, I need to do something in the outside world, like look up the time. But if the model needs to process a big chunk of data, it has to push that entire thing back into its own context window to read it.
And that costs a ton in tokens.
A ton, even if it only needs to check one little variable inside a huge file.
So what's the hack?
The hack is to shift to a code execution environment. Instead of that traditional MCP tool call, the agent literally writes code, like a Python script, that interacts with those same services as if they were just standard APIs.
Ah, so it does the heavy lifting outside the LLM?
Precisely. The script processes all that data locally, outside the expensive context window, and then just returns a tiny structured result, maybe a few hundred tokens, to the main model for the final decision. This one change cut token usage by an astonishing 98.7%.
That is a staggering business advantage. Wow.
It's huge.
But, all the AI efficiency in the world means nothing if your foundational infrastructure just collapses.
Right.
So, speaking of dodging catastrophes, let's pivot. When AWS East 1 went down recently, a lot of major companies stumbled. But Authris stayed up. What was their secret?
It was just good engineering hygiene deployed flawlessly. Their success wasn't some secret cloud provider. It was just redundancy baked deep into their architecture.
So what did they do specifically?
Well, for one, they strictly avoided unreliable third-party components. Those often become single points of failure.
The weakest link.
Exactly. And crucially, they had DNS failover with custom health checks, so traffic only redirected when it absolutely had to. And they leveraged Edge Compute CloudFront and Lambda at Edge to keep their auth services running even when the main data center was on fire.
So they decoupled critical services from the main region, a
Mhm.
classic defense-in-depth approach.
That's it. It just recognizes that failure is inevitable. And then on the other side of that coin, you have Cloudflare,
A service designed to prevent downtime.
having a catastrophic widespread 5xx error outage. And of course, when that happens, everyone immediately screams, DDoS attack.
But the truth was so much more mundane, wasn't it?
Depressingly so. It was a faulty configuration file in their bot management system, of all places.
A config file. How does one config file take down Cloudflare?
Well, they made a database permissions change, and that change unexpectedly caused this config file to swell to a massive size. And when that oversized bad file propagated across their network, it just overloaded their traffic routing software. Global failures.
No hackers.
Yeah.
Just one really big bad file.
Yep. The lesson is always that scale and complexity turn tiny little errors into global incidents.
Speaking of simple, costly errors, let's talk about the infamous $1,000 AWS mistake.
Ah, the geocodio lesson. I bet someone got a very quiet, very early morning phone call after this one.
So what happened?
It's a lesson every dev needs to just engrave on their monitor. They got hit with these huge, unexpected data transfer charges because traffic between their EC2 instances and their S3 buckets was routing through a NAT gateway.
Even though they were in the same AWS region.
Even in the same region. And NAT gateway traffic, even if it's internal, is expensive.
I think most people assume traffic inside a region is basically free. Why would it even go through the NAT gateway?
It goes through if your subnets are configured to use it as the default route for any outbound traffic. Crucially, it takes that pricey route because there was no direct private endpoint setup.
And the free solution was?
The free solution, which they found out the hard way, was to implement VPC Gateway Endpoints for S3. It just establishes a private connection using AWS's internal network. The traffic never touches the internet. It never touches that expensive NAT routing layer. It's a direct free route.
It's a tiny configuration setting that saved them thousands.
Exactly.
So as we move from infrastructure up the stack to the tools developers are using, let's talk performance. How are modern front-end frameworks like Next.js handling that delicate dance between static and dynamic content?
Well, the big evolution there is partial pre-rendering, or PPR, in Next.js 15. PPR is that technique where you serve the static shell of a page instantly, and then the dynamic parts hydrate on the server. The key update in Next 15 fixed a really serious issue from the last version.
You're talking about the error-throwing mechanic.
The error-throwing mechanic. The first version of PPR literally threw an error to detect when a component was trying to access request time data, like headers or cookies, during the static build.
And that did not play well with existing try-catch logic.
It was a disaster. It caused all of these unintended runtime failures. So now they've switched to a promise-based system. The request APIs, like cookies or headers, are now async, and they return a never-resolving promise during pre-rendering.
A never-resolving promise. That sounds weirdly elegant. Why does that work?
Because it's a standard, clean way to just block execution until the server can actually fulfill that request. But it does it without crashing the static build with some random exception. It just integrates cleanly with normal async JavaScript. It's much less brittle.
Speaking of performance, let's talk syntax highlighting. It seems like a small thing, but on doc sites or in web IDs, it can be a real performance hog.
Oh, absolutely. The traditional way, inserting thousands of little span elements into the DOM, can cause massive memory usage and reflows.
So what's the modern DOM-free way?
The alternative is the CSS Custom Highlight API. This is a game changer. It completely decouples the presentation, the colors, from the document structure.
So you're not bloating the DOM anymore.
Not at all. You use the API to just register arbitrary text ranges, and then you style them directly using the CSS Highlight pseudo-element. The browser engine handles all the styling during its normal rendering pipeline. No more costly DOM recalculations.
So the performance boost must be huge.
It's immediate and very significant for any heavy text-based app.
Now let's get a bit philosophical. We're seeing this big movement promoting what's called just JavaScript. What does that ideology actually mean for a developer today?
It's a call for simplicity and maintainability. Just JavaScript is code that works without any proprietary custom build time transforms or unique language semantics.
Meaning the code you write is the code that runs.
Exactly. It means anyone who knows standard JavaScript can understand it and refigure it without having to learn a bunch of framework-specific magic.
So who's the poster child for this?
Remix 3 is adhering very strongly to this. On the other side, you have great frameworks like Svelte or even React, which, because they rely on custom transforms like JSX or unique language features, they don't really fit that just JavaScript mold.
So it's a choice between simplicity and feature encapsulation.
That's a great way to put it.
And if you're on the back end, specifically with Ruby, Datadog shares some crucial performance findings.
Yeah, the critical takeaway there is how Ruby apps spend their time. They found that a staggering 82% of CPU time is spent in library code.
82%.
Right. Which means performance optimization in the Ruby world isn't just about your own code, it's about being extremely careful with your library choices.
So what are the quick wins?
The simple wins are upgrading to Ruby 3 to get YJIT, the just-in-time compiler, which helps a lot, and then replacing older libraries, like swapping out MySQL 2 for the more efficient trilogy.
Okay, from optimizing backends, let's leap right into the fire. The great programming debate. Let's talk about the statement that object-oriented programming is the worst thing that happened to programming.
It's provocative for sure.
It is, but what's the actual critique here?
The argument is that the core concepts of OOP, especially deep inheritance and managing mutable state across dozens of classes, they just lead to unnecessary complexity.
Verbose code.
Very verbose code. And it forces developers to use all these complex design patterns, factories, singletons, which the critics argue are really just complicated workarounds for the problems OOP created in the first place.
So the complexity becomes the problem, not the solution. But surely you need that structure, that separation of concerns for big enterprise systems.
You do, but the argument is that how we achieve that separation has shifted. OOP hasn't disappeared. Its principles have just been generalized up a level.
What do you mean?
The principle of separation of concerns is now being applied at the process and network level. We're replacing class-level OOP with microservices, Docker, and Kubernetes.
Oh, wow.
And the critics call this something worse. We've traded the complexity of class hierarchies for the vastly more difficult complexity of distributed systems.
Network latency, serialization issues, eventual consistency.
All of it. So in a dark way, the microservices revolution is just distributed OOP for the network stack.
That's a chilling thought.
Yeah.
Now let's talk security. Specifically, a privacy threat you might not even realize is tracking you. The super cookie.
This is a wonderfully devious piece of tech. The super cookie exploits the way browsers cache favicons, those little icons in your tabs.
Okay, how?
Because that favicon cache is designed to be extremely persistent. It often survives clearing your history, clearing your cache, all the normal things you do.
So it's a blind spot. How does the tracking actually work?
A server can direct your browser to load a unique ordered combination of favicons, and that combination creates a persistent binary fingerprint for you.
A fingerprint.
So when you come back, even in incognito mode, your browser quickly checks its favicon cache. The server sees which unique combination of icons it requested, reconstructs the fingerprint, and knows it's you.
That's persistent tracking that survives most user defenses. That is a huge blind spot in browser security.
It really is.
And from subtle tracking to just outright technical debt, we have to talk about AI slop.
Ah, yes. Bloated, buggy, architecture-free code. We saw a perfect storm of this with a security incident at Okta.
This one was a mess.
A total mess. A developer responsibly reports a vulnerability in an open-source Okta project and submits a patch. The maintainer, trying to be efficient, uses an AI tool to rebase the commit.
Sounds like a decent use case for automation, right? Basic repo hygiene.
It should be, but it failed catastrophically. The AI completely messed up the rebase. It removed the contributor's entire commit history and gave incorrect attribution.
Okay.
And when the original developer pointed this out, the maintainer doubled down, used an AI again to generate this robotic, poorly written apology, and then refused to manually fix the commit history.
That's a failure of management and responsibility, not just a tool. It highlights how fast AI can create these huge transparency and integrity problems, especially in security.
Exactly. But wait, are we really still seeing in 2025 PII being exposed because an API lacks simple rate limiting?
Apparently so. The Avelo airline API vulnerability.
It's almost unbelievable. A researcher got access to millions of passenger records, we're talking PII, government ID numbers, through a simple brute force attack.
Because the API had no rate limiting and didn't properly verify last names?
If you don't limit the number of automated guesses a script can make, you are guaranteeing a data breach. It's just a matter of time. It's a failure of the most basic security review.
So we've covered the whole spectrum today. From, this high-tech chase for a 98% token reduction.
All the way down to a single oversized config file crippling a global network.
It really summarizes the dual state of modern engineering, doesn't it? We're inventing these brilliant architectures for AI agents, but we're still struggling with the most fundamental lessons in reliability and security.
It really emphasizes that the difference between success and a catastrophe often isn't the LLM you choose.
No.
It's the VPC endpoint you forgot to configure, or the rate limit you just neglected to set.
And that ties directly back to our reliance on these big centralized services. That Cloudflare outage was such a stark reminder. We came across this 2-minute opinion suggesting that many smaller sites, they don't actually need Cloudflare's massive DDoS protection. And they're just unnecessarily exposing themselves to its downtime risk.
So what's the alternative?
The truly redundant solution is often just a simple round-robin DNS with a backup server that you completely control.
We're building these massive, complex systems, but the internet's reliability still comes down to these individual components. You have to question your reliance on them.
You have to ask yourself, are you sure your backup plan isn't relying on a component that just failed for everybody else?
That's the question.
Absolutely. Focus on that foundational hygiene. And while you're optimizing your own workflow, check out great tools like Parquet. It's a terminal utility for inspecting Parquet files. Or Guts, a Go library that converts Go types directly to TypeScript.
Keep learning and keep questioning the foundations you're building on.
We'll catch you next time.
Spoken Tech for your ears.